how quantum sensors could detect parallel universes. All around us is a universe we can't see, a hidden cosmos that makes up the vast majority of everything. To find it, scientists are building the most sensitive devices in history, capable of hearing the faintest whispers from space. But what if, in the search for one of the universe's greatest secrets, they stumbled upon its most profound one, a signal from a reality right next to our own? And no, this isn't just a late-night sci-fi plot. This is a story about how the hunt for dark matter is pushing us to build technology so incredibly sensitive, we might accidentally eavesdrop on another universe. Now let's be clear, these machines are not being built for that. But at the absolute edge of what we can measure, the line between our reality and another could theoretically begin to blur. Section 1. The Invisible Universe. So how could this even be possible? First, you have to get your head around just how much of our own universe is a total mystery. Everything you can see, every star, planet, and galaxy, is made of ordinary, normal matter. But all of that adds up to only 5% of the cosmos. The other 95% is a ghost. It's split into two different things. About 27% is dark matter, and 68% is dark energy. We know they're there. We see their effects everywhere. Dark matter is the invisible glue holding galaxies together, making them spin faster than they should. Dark energy is the mysterious force that's pushing the entire universe apart, causing its expansion to speed up. But we have no idea what either of them actually is. They don't interact with light, which is why we call them dark. They pass through you and me and the entire planet as if we aren't even here. For decades, we've been trying to catch a dark matter particle. We've built huge detectors deep underground, shielded from cosmic radiation, hoping for a lucky break, a single rare collision. But so far, nothing. Zilch. That persistent silence has pushed physicists to a new frontier. If dark matter is even quieter than we thought, we need a better ear. We need to go quantum. Section 2. The quantum ghost traps. This is where quantum sensors come in. These aren't just better microphones. They're a whole new way of listening to reality, built on the strange rules of quantum mechanics. Think of a pond so perfectly still that a single speck of dust landing on it sends ripples across the entire surface. That's a quantum sensor. They are engineered to be so isolated from the noise of our world that they can feel the tiniest, most subtle disturbances. At Oak Ridge National Laboratory, for instance, scientists are building optomechanical sensors for this exact reason. They use a weird trick called squeezed light, which is a special quantum state where you quiet down the noise in one property of the light to get a super precise measurement in another. It lets them hear signals that would normally be drowned out in the static, like the incredibly small nudge a dark matter particle might give to a tiny sensor. Meanwhile, researchers at places like Fermilab are working with things called superconducting nanowire single photon detectors, or SNSPDs. Think of them as ultra-fast, ultra-sensitive cameras that can detect a single particle of light. A recent variation, called an SMSPD, proved it could also detect high-energy particles with incredible precision, an essential tool for sifting through the shrapnel of particle collisions to find something new. These are just a couple of examples of a revolution in measurement. From atomic clocks that would lose only 1 second in 300 billion years, to gravimeters that can detect tiny shifts in Earth's gravity, we're getting ridiculously good at measuring things. The main goal is to finally catch the ghost of dark matter. But when you build the perfect ghost trap, you might just catch a different kind of ghost. Section 3. The wall between worlds. This brings us to parallel universes. It's a wild idea, but it has surprisingly deep roots in theoretical physics. You might have heard of the many worlds idea, which says the universe splits into a new branch for every possible quantum outcome. A universe where you turned left, and another where you turned right. But there's another more testable idea from string theory called brain cosmology. It suggests that our entire universe, with its 3 dimensions of space and 1 of time, is just a membrane, or a brain, floating in a higher dimensional space, sometimes called the bulk. Imagine our universe as a single sheet of paper in a giant library. Brain theory says there could be other sheets of paper, other universes, on other shelves, maybe just millimeters away from us, but in a direction we can't see or point to. In this picture, most of the forces of nature are stuck to our sheet of paper. But gravity, the theory goes, is different. Gravity is a property of the higher dimensional space itself. It isn't stuck. It can leak between brains. And this could be a potential answer to one of the biggest puzzles in physics. Why is gravity so much weaker than all the other forces? Maybe most of its strength is just leaking away into these other dimensions. It's a mind-bending thought. Entire universes floating just out of reach. If you want to keep exploring the absolute edges of science, from the impossibly small to the cosmically vast, think about subscribing. We tackle mysteries like this every week, and you won't want to miss where we go next. Section 4, the cosmic eavesdrop. So how does a quantum sensor built to find a particle in our universe hear a whisper from a different one? Well, it wouldn't see it. It would feel it. If another brain universe exists close to ours, its gravity could leak across that tiny dimensional gap and nudge things on our side. And that's the key. The dark matter experiments aren't just looking for particles. They're looking for any tiny, unexplained wiggle of energy or force that doesn't fit with what we already know. A signal from a parallel universe wouldn't be a radio message. It would be an anomaly, a gravitational pull from nowhere, a quantum sensor jiggling when it should be perfectly still, a weird particle showing up in a detector that seems to have come from thin air. This is where the ideas slam together. The optomechanical sensor at Oak Ridge, using squeezed light to look for a kick from dark matter, is also the perfect device to search for a tiny gravitational whisper from another dimension. A detector at a future particle collider could register a particle that didn't come from the collision, but instead, theoretically, popped into our brain from another. There's even a real, though highly speculative, concept called the neutron passing through walls experiment. The idea is that a neutron in a nuclear reactor could, with a very, very small chance, swap places with a hidden neutron in another brain. In that hidden state, it would be invisible to our matter and could fly straight through a thick wall. On the other side, it could swap back and be detected. Experiments looking for this effect have actually been run, and while they found no evidence, it shows that physicists are actively looking for the cracks in our reality. Section 5. The search in the static. Needless to say, this is unbelievably difficult. The biggest problem is noise. If your sensor wiggles, how do you know it's another universe and not just a passing truck, a tiny earthquake, or a stray cosmic ray? Telling a real signal apart from a million sources of everyday background noise is one of the hardest jobs in science. The other issue is that we don't know what we're looking for. It's like listening for a specific sound without knowing if it's a drum beat, a whistle, or a hum. Theorists are still working on a clearer map that could tell the experimentalists what a signal might actually look like. Finally, there's the problem of scale. Many of these quantum sensors are still prototypes. To have a real shot at finding something so rare and so faint, we need to build huge networks of them, all working together to rule out false alarms. No experiment being run today is officially a parallel universe detector. But here's the crucial point. They don't have to be. The race to find dark matter is forcing us to build devices that are, by their very nature, also sensitive to the kinds of weirdness that might signal a nearby reality. Every time we get better at looking for dark matter, we're accidentally getting better at listening for something else entirely. Conclusion. We've mapped our world, our solar system, and our galaxy, only to find that we can't explain what 95% of it is made of. In our quest to find the missing pieces, we're building machines that operate at the very edge of what's possible. We're building quantum ears to listen for the whispers of dark matter. We may well find it. But in listening so closely, with technology so sensitive it seems almost magical, we might just hear something we never, ever expected. A tiny tremor in space-time, an impossible particle, a whisper through the static from a universe layered right on top of our own. The hunt is on, and the prize might be bigger than any of us ever imagined. What do you think? What would it mean for us if we found out we're not alone in the cosmos, not because of aliens, but because of another universe? Let me know your thoughts in the comments. Thanks for journeying to the edge of reality with us. If you had fun with this one, hit that thumbs up button and subscribe for more deep dives into the science that's changing our world. And if you want to get even weirder, check out our video on the quantum eraser experiment right here. See you in the next one.